Section B. Okay, let's go for it. Hard work. Question 9. Which is the correct crystal structure for a substance named? Diamond ionic? No. Sodium chloride giant covalent? No, that is giant ionic lattice. Graphite metallic? No. Iodine simple molecular? Yes. And you do need to know these structures of. So this is basically an AO1 question. Because it's just testing your knowledge of the structures of each substance. Which is the best technique to remove the silver chloride that forms when aqueous solution of sodium nitrate and sodium chloride react? Refluxing, no. Evaporation, no. Filtration, yes. Distillation, no. Question 11. Which statement about astatine is correct? Astatine has a greater electronegativity than bromine. Let's look at the periodic table. Astatine and bromine. Where is bromine? Bromine. There. Astatine is lower down the group. So actually, astatine has a lower electronegativity than bromine because it's lower down the group. That's false. Astatine is better oxidizing agent than bromine. No, it's actually going to be a worse oxidizing agent than bromine. Astatine has a greater boiling point than bromine. Let's think about it. Astatine is further down the group, right? More electrons. Stronger intermolecular forces require more energy to overcome. So astatine will actually have, and remember, melting point increases down group 7. So astatine will actually have a greater boiling point than bromine. 12a, which statement about time of flat mass spectrometry is correct? The current in the detector is proportional to ion abundance. That is absolutely true. Let's look at the other statements. Let's see. Sample particles gaining electrons to form positive ions. If you're gaining electrons, you're going to form negative ions. You lose electrons to form positive ions. See, particles are detected in order of the kinetic energies. No, they all have this order of the mass number, the mz value. They all have the same kinetic energy. Ions are accelerated by a magnetic field. It's an electric field. So yeah, it's just testing your knowledge on time of flat mass spectrometry. Question 13. Which statement about peaks in mass spectrum of chlorine is correct? Peaks at MZ 70 and 74 in a ratio of 3 to 1. Peaks at MZ 70, 72 and 74 in a ratio of 9 to 61. Yeah, it's going to be B. 13B is the correct answer. Question 14. What was the concentration of sodium sulfate in the solution? It gives me the mass of the sample and it gives me the volume. And we're trying to find the concentration, so I'm going to have to find out the moles first. So the moles is going to be the mass of the MR of sodium sulfate. Sodium sulfate. How do we find out MR of sodium sulfate? Sodium sulfate. Sodium's charge is +1. So +1. A sulfate ion, SO42 minus. So if you do the crisscross method, you should get 2 NaSO4. I'm just gonna Google it because this is really important, because if we get the MR wrong, we're gonna get the moles wrong, and if we get the moles wrong, we're gonna get the concentration wrong, so we're gonna get the whole mark wrong. The mark we worked for. It is Na2SO4, not 2NaSO4. And that actually makes sense, because this 2 goes here. It doesn't mean that, there's 2 of this and the 2 of this. It doesn't mean that. So it means it's Na2SO4. So now if we find out the MR, Na2SO4, Na2SO4. So sodium 23 plus 23 plus sulfur 32.1 plus Na2SO4, 4 oxygens plus 64. 142.1. No 0.0341 moles. And remember, moles of concentration, volume concentration, moles divided by volume. But I want the volume in its correct unit, so 250 times by 10 to the power minus 3. I should get 0.137. So B. Which of these contains the greatest number of atoms? A lot of calculation questions in this paper. Very annoying. Not that annoying, but it's just going to take a whole lot longer to finish off. Which of these contains the greatest number of atoms? 127 milligrams of iodine. No. 1.54 times by 10 to the power minus 4 kilograms of phosphorus, but we want that in grams. So if we convert this into grams, I will get... Well, how do you go from kilograms to grams? Divide by 1,000, right? And if we want to go from grams... No, oh my days. Yeah, you can tell me I've been doing a lot of videos recently. Kilograms to grams, we times by 1,000. There's 1,000 grams in every kilogram. Can't believe I just got that wrong. So 1.54 times 10 to the power minus 4 times by 1,000. 0.154. In this case, it can be 0.170 grams. Grams. How do we go from milligrams to grams? Grams to grams. Well, we're gonna time milligrams to grams. We're gonna divide by 1,000. Yeah, so it's gonna be, so it's definitely not gonna be this or this. So then we've got B or D. Well, that's bigger than that, so the answer is D. 15D. Can't believe I got this wrong. Kilograms to grams, obviously we times by 1,000, and grams to kilograms divided by 1,000. Which of these could explain the difference? 25 centimeters cubed of NaOH was taken by pipette from a beaker. These were then titrated in an aqueous solution of ethanoic acid. The concentration of ethanoic acid calculated from the experimental results was found to be lower than actual value. So the concentration of ethanoic acid calculated from the results was lower than actual value. Which of these could explain the difference? Rinsing the pipette with distilled water before filling with sodium hydroxide. No. Rinsing the burette with distilled water before filling with ethanoic acid. Definitely. What is the formula of metal bromide? 20 centimeters cubed sample of this much of a metal bromide reacts exactly with this much of silver nitrate. What was the formula of metal bromide? So, first thing I would do is I'd find out the moles. I don't know what I'm working out the moles for or what, I'm just finding out the moles. So 20 divided by 1,000 times by 0.40. Because it is a 1 marker, it can't be like incredibly hard, right? Then we can find out the moles of this, and I get 0.016. And what is 8 times by 10 to the power minus 3? It's 0.008123 to 0.016. 123. Yeah. So what is that? That's a 1 to 2 molar ratio. So therefore the answer must be B. That's the moles of M and Br. So MBr2 is the formula of metal bromide. Which species has one or more bond angles of 90 degrees? CH4, that does not have any angles of 90 degrees. NH4 plus, same with that, does not. ClF4 minus or AlCl4 minus. ClF4 minus, so we're going to add an electron. ClF4 minus, yeah, it will have a bond angle, one or more bond angles of 90 degrees. Question 19, in 4 directions, equilibrium is endothermic, so delta H is positive. which statement is correct? I don't know the value for delta H, but if it gives me some numbers, then I could possibly work it out, but that's not what the question wants me to do. If the total pressure is increased at constant temperature, proportion of CO2 will decrease. Well, if the total pressure is increased, the equilibrium won't suppose that, therefore it wants to decrease the total pressure. Therefore, it's going to shift to the side with fewer moles of gas. No, if the total pressure is increased, it wants to decrease that by shifting to the side with fewer moles of gas. Yeah, so that means the proportion of CO2 will actually increase, it won't decrease. That's wrong. Use of a catalyst will increase the proportion of CO2 in the equilibrium mixture at constant temperature and pressure will increase the proportion of this in the equilibrium mixture. No, catalyst cannot affect the equilibrium yield. Reducing the equilibrium concentration of CO will increase the value of equilibrium constant. What is equilibrium constant? Kc products to the power of P over reactants to the power of R. And if I'm reducing the equilibrium constant of CO, that's a product. So I'm going to have a smaller total number of products, but I'm going to have the same number of reactants. What will happen to the value? It's saying it will increase the value of equilibrium constant. That's false. If I've got, let's say, 10 divided, let's do bigger numbers, make it simpler. Actually, let's do, 10 divided by 15. If I decrease this 10 to 9, or to actually 5 over 15, which one is a bigger number? 5 over 15 is 0.333. 10 over 15 is 0.66666. So actually, what will happen to the value of equilibrium constant will actually decrease. It won't increase. Raising temperature from 373 Kelvin to 473 Kelvin increase the value of equilibrium constant. Yes. I should have just said this before. Only temperature can affect the value of equilibrium constant. So it couldn't have been C anyway, because only temperature can affect the value of Kc at equilibrium constant of Kc. Next question. Which of these is not a redox reaction? And that's it. It's not a redox reaction. So what is a redox reaction? Redox reaction is when the oxidation state goes up and it goes down. That's a redox, right? That's why it's called, because it includes oxidation and reduction, therefore it's called redox. Ox and a read. So if we look at the oxidation state of copper, that's 0. Look at here, well that's -2, so that's going to be +1. So that definitely decreases. But if we look here, that's -8, oxygen -2 times 4 -8. Sulfur is in group 6, -2 charge, so -10. So it's going to be +10 here. So does the oxidation state increase? Yes. Does the oxidation state decrease? Yes. So therefore that is a redox reaction. Magnesium oxide, well that's magnesium, oxidation state of magnesium is +2. And in this case it is -1 -2 is also +2. Answer is B. Because redox reaction is when the oxidation and reduction happen. But in reaction B, the oxidation state stays the same. It doesn't increase, it doesn't decrease. Therefore, that is not a redox reaction. That is just your normal reaction. Question 21. Which of these has the highest first ionization energy? So in order to have the highest first ionization energy, we want to look for the atom or the element for the atom that has the highest nuclear charge while also in the smallest period. So if we look at sodium, that's in period what? That's in group 1, but not the period. The period is 1, 2, 3. It's in period 3. Aluminium is also in period 3. Silicon is also in period 3. And let me guess, chlorine is also in period 3. Yes, it is. Which of these has the highest first ionization energy? Well, chlorine is definitely the... Oh, just a key fact. Ionization energy increases. Ionization energy decreases down a group and increases across a period. It's going to be chlorine. Using the simple key fact that ionization energy increases across a period. Increases across a period. That's why memorizing trends can be useful a lot of the times. What is the empirical formula? Oh shoot. Oh shoot. Oh no. It's fine. Hopefully it still works. Okay, so we'll refresh, but it's fine. What is the empirical formula of an oxide of nitrogen contains 26% nitrogen by mass? Okay, so 26% nitrogen by mass. So if you look at this case, the MRs, nitrogen and oxygen. Well, nitrogen is 14, so 14 divided by 14 plus 32, which is 14 over 46, which is not 26%. In this case, actually I'm just going to put in my calculator, 14 plus 14 over 16 plus 16 plus 16 plus 14 plus 14, that is 36%, so it can't be that. 14 plus 14 over 14 plus 14 plus 16 plus 16 plus 16 plus 16 plus 16. That is 0.259%, so it probably is that, but let's just check. D 14 plus 14 plus 14 plus 14 over 14 plus 14 plus 14 plus 14 plus 16 plus 16 plus 16 plus 16 plus 16. That is 41%, so the answer is C. Rounds to 26%. Multiplied by 100. Which species is not produced by redox reaction between solid sodium iodide and concentrated sulfuric acid? This is the equation you do have to learn off by heart. And solid sodium iodide and concentrated sulfuric acid is not produced. Let me find out. Let me go through my textbook and write down an equation, just so we can see how, if we knew the equation, it'd be very easy question. So let me find out. Wow, there's 3 parts of the equation. Between solid sodium iodide and concentrated sulfuric acid, the one that you don't form is actually Na2SO4. Here's the equations. NaI plus H2SO4. I'm not going to include the states. That's going to take a lot of time. NaI plus H2SO4. NaHSO4 plus HI. 2HI plus H2SO4 arrow I2 plus SO2 plus 2H2O. 6HI plus SO2 arrow H2S plus 3I2 plus 2H12. So have we formed hydrogen sulfide H2S? Yes, we have. Have we formed sulfur? Yes, so SO2, yes. So the answer is obviously A, Na2SO4. That is the end of the multiple choice questions.